Okay, question 17. Solid sodium iodide reacts with concentrated sulfuric acid to form more than one product that contains sulfur. What is the lowest oxidation number of sulfur in these products? Now, this can be a very challenging question if you think you're going to need to learn all these equations. Okay, but really, I don't think it's ever going to be necessary, or at least I hope it's not going to be. First of all, let's think about what is this all based on? This is from your halogens topic, and it's based on the reaction of halides with sulfuric acid, okay? Now, when you react a halide with sulfuric acid, the sulfuric acid is acting as a powerful oxidizing agent, okay? So I'm just going to put O or OXA there, so that's an oxidizing agent, which means itself will be reduced if it's allowed to act as an oxidizing agent, okay? Right, so just before we move on, it's very important that you realize that your halides will behave differently depending on which halide you're on about, okay? So the chloride, bromide, and iodide ions are going to behave differently. And the best way to think of it is that the lower down in the group that you go, in other words, you're going to have to go as low as iodine only, okay? So your iodide is going to be the most complex because it's going to be the one that is taking part in more reactions than any of the others. Now, I've written out all the possible reactions that are going on here, okay? So if you react sodium iodide with sulfuric acid, you're going to produce this salt and the hydrogen iodide gas, okay? Now, this will be the same for your chloride ion and your bromide ion. In each cases, you're going to form your hydrogen halide, okay? So hydrogen chloride gas or hydrogen bromide gas, you're always going to form that, okay? And that's very important to know. But there has been no reduction of the sulfuric acid in this first part of the equation, okay? Now, in the case of sodium iodide, the hydrogen iodide produced there is going to be further oxidized. In other words, the sulfuric acid is going to be further reduced, and it basically can take three different pathways. So the hydrogen iode can further react with the sulfuric acid to produce sulfur dioxide in this case. It can further react with sulfuric acid to produce sulfur and further to produce hydrogen sulfide. So instead of learning these three equations, the best thing to do probably is just to understand that you're going to produce sulfur dioxide, sulfur, and hydrogen sulfide when you react sodium iodide or when you react an iodide with the oxidizing sulfuric acid. And what your question is asking you here is what is the lowest oxidation number of sulfur in these products? So just to be clear, I think it's way better you just learn that there are three potential products or sulfur products when you react sodium iodide with sulfuric acid: sulfur dioxide, a sulfur, and hydrogen sulfide. So what is the oxidizing what is the oxidation state of sulfur in this situation, situation 1? Well, we've got 2 times -2 there for the oxygen, so that means our sulfur is going to be +4. Now remember, in each case here, the sulfuric acid is being reduced essentially, isn't it? So this sulfur, this oxidation number should be dropping as we go from equation 1 to 2 to 3. Okay, in this second equation here, our sulfur is going to have an oxidation state of 0 because it's in its atomic or elemental form. And in this third one here, you're getting the hydrogen sulfide being produced, and hydrogen being +1 means that the sulfur here is going to be -2. So what is the lowest oxidation number of sulfur in these products? The answer is going to be A, -2. Okay, so that's the explanation for the answer there. But I do want to add a couple of points. If this was a question about sodium chloride, okay, then you wouldn't have any of this happening. You wouldn't have this equation 1, 2, or 3 happening because the sulfuric acid would not be a powerful enough oxidizing agent. In other words, your equation would just end here where you're forming your hydrogen chloride gas, and that would be it. In the case of sodium bromide, you would have your hydrogen bromide gas forming, and you'd have further reduction of the sulfuric acid to produce sulfur dioxide, but you wouldn't have equations 2 and 3 happening. So it's also important you realize what's going to happen with your different halides as they react with sulfuric acid. I hope that has helped.